Hey guys, in the previous video we understood that what is parallel projection. So in this video now we are going to understand that what is perspective projection and what is the difference between the two. So a projection is said to be perspective projection if the center of projection, or also known as the COP, is at a finite distance from the projected plane. Now you must remember that in a parallel projection, the COP, or we can say that the center of projection, is present at infinity. That is, in parallel projection, the COP is present at infinity, whereas the center of projection or the COP in perspective projection is present at a finite distance from the projected plane. And this perspective projection is similar to a human vision system, that is how our eyes perceive an object, that is how we see an object. It is similar to what is perspective projection, that is we also use the method of perspective projection in order to view objects. Now the object appears smaller or as the distance from the center of projection of the COP or the projection increases. That is, suppose this is the image plane and this is your object, and we are projecting this image on this object on this image plane. Now if we increase this distance, that is this distance, or we can say that if we increase this distance, say x, if this distance increases, then the object will appear, or the object will appear smaller as compared to when it was able to when it was nearer to the image plane. So by third point we can see that the object appears smaller as the distance from the center of projection increases. And now let us come to the fourth point. It is difficult to determine the exact size and shape of the object. Like at a distance, if we see an object from a distance, it is difficult to tell the exact size and the shape of the object, where this is the case in perspective projection. Now let us see how an image is projected using perspective projection. Suppose this is the image plane and we have an object AB, say over here, and we are going to project its image on this 2D plane. So we will not be drawing parallel lines now as we did in the previous projection, that was parallel projection. Now we are going to draw the convergent lines, or the convergent rays, which will meet at a finite distance, which is known as the COP. That is, they will meet at a convergent distance, and these are the projection rays. And this is the projection plane. And this is point A dash and B dash. Now guys, this is how perspective projection is done, which is quite different, or which is completely different from parallel projection, in which we use parallel lines to project an object on the image plane. And over there the COP is present at infinity. But whereas in perspective projection the COP is present at a finite distance. It is present at a finite distance. Now guys, these are the points for perspective projection. Now let us see that how we will be deriving the equations of the rays in perspective projection. That is, let us come to the derivation part. That is, this is the derivation. So let us consider an axis. First let us draw the 3D coordinate system in which we have x, y and z axis, and suppose we have a cuboid over here. That is, we have a 3D object. Now this is the COP. So we will be now drawing convergent rays towards the COP, so that we can do perspective projection. Suppose this is the x and this is the y plane and this is the z plane. So now we are going to project this 3D object into its 2D plane, that is over the 2D image will be created. That is over here. That is that is a 2D object, or 2D image, 2D image is displayed of this 2D object using perspective projection. And this is the COP, which is present at a finite distance from the image plane. That is, xy axis or the xy plane is the image plane. Now let us consider the center of COP is xc, yc and zc. That is this point, or we can say that the coordinate of COP is given as xc, yc and zc. Let us write it here. That is, the coordinates of COP are xc, yc and zc. And then secondly, the point on the object is given as x1, y1 and z1. That is the object point, which will be given by x1, y1 and z1. That is this plane. Now we will be seeing that the projection ray will be a line containing 3 points, and it will be given by these 3 equations. That is, these are the lines, these are the projection lines, and these will contain 3 points, which will contain these 3 parametric equations. That is, we have x is equal to xc plus x1 minus xc into u. Then we have y is equal to yc plus y1 minus yc into u. Then we have z is equal to zc plus z1 minus zc into u. Now this is the parametric form of the points which will be present on the projection rays. That is, these are the projection rays, and the points present on these rays is given by these 3 parametric forms. Now, as we discussed earlier, that we are going to project a 3D object into a 2D plane. So in a 3D object, we have the coordinates as x, y and z. Whereas in a 2D plane, we do not have the x-axis, we only have 2 coordinate systems, that is x and y. There is no z coordinate over here, as we discussed in the parallel projection plane. So now, as we had done previously, we will be now putting this z value as 0, as on the 2D plane there will be no z. So on doing so, let me change the color. On doing so, you will get 0 is equal to zc plus z1 minus zc into u. And on doing that, you will get the value of u as minus zc upon z1 minus zc. That is, u is equal to minus zc upon z1 minus zc. Now we will use this equation, that is, say, equation A, and we will put it in equation 1 and equation 2. That is, on doing so, we will get the value of x as x will come out to be xc minus z1 minus x1 zc upon z1 minus zc. So this is what we will get when we will equate, or when we will put this equation, that is A equation, in equation number 1. Now similarly, we are going to use A equation and put it in equation 2 in order to get y. That is, we will get y as y is equal to yc minus yc z1 minus y1 zc upon z1 minus zc. So these are the coordinates, or these are the points that we will get by putting y equal to minus zc upon z1 minus zc in these 2 equations, that is, in equation 1 and equation 2. Now we are going to write this in homogeneous form, or we can say in the parametric, or in the metric form, that is, in a form of a matrix. Suppose we have to find point P, and then we have x, y, z, x1, y1, z1. And in order to write this in a 4 cross 4 form, we will be putting 1 over here, so that it is in the homogeneous form, which is a 4 cross 4 form. And over here we will get minus zc 0, 0, 0, 0 minus zc 0, 0, xc, yc 0, 1. We will get over here 0, 0 minus zc. So this is what we will get on finding out the matrix form using these 2 equations. That is, these 2 equations can be represented in the form of a matrix as written below. That is, when you will open this matrix, or when you will multiply these 2 matrices, you will get the same equations, same parametric equations that as we had got earlier. That is, these 2. So guys, this is it for perspective projection. In this we discussed that what is perspective projection, and it is similar to human vision system, and that the COP is present at a finite distance, which is different from parallel projection, in which the COP is present at infinite distance. Now in this, the objects appear smaller depending upon the distance of the center of projection. Now, and it is difficult to find the exact size and shape of the object. Then we saw, with the help of a diagram, that how we have to do parallel projection and how it is done in order to draw an image of an object on a 2D plane. Then we saw the derivation, in which we took a 3D object and displayed it on the xy plane. And we took the coordinates of the COP as xc, yc and zc. Then we took the point on the object as x1, y1 and z1. Then we wrote the parametric equations for these 3 points which will be present on the projection rays. That is, these are the projection rays. Now we know that we are projecting the image on a 2D plane, that is this. So only x and y will be present and z will not be there, as we are only talking about the 2D plane. So we will put z equal to 0, and on doing so you will get y is equal to u is equal to minus zc upon z1 minus zc, and we will use this in these two equations. And on doing so we will get the value of x and y as this. And then we will write these two equations in the form of a matrix or in the homogeneous form, that is this form as we are written right now. So guys, this is it for this video. If you were able to understand this video and the concept displayed over here, just write wow in the comment section, and it would be great to know that you were able to understand it. And guys, before leaving, do not forget to subscribe our channel, as it gives us the hope and gives us the motivation in order to create more such videos. Now guys, this is it for this one. See you in the next video.